Lopez of GARNET from the University of Nueva Cáceres, Ayala Education, Junior High School. So today, I'm gonna show you how to create a star topology using a Cisco packet tracer. So let's get started!
So before we start, let us first define what is network topology. Network topology refers to the layout or structure of the network in relation with the flow of data. It is the way in which the elements such as computers, printers, servers, and other computing appliances are arranged in a network. Network topology includes linear bus topology, ring topology, mesh topology, hybrid topology, and star topology. In this tutorial, we're going to use the star topology. Let us first define what is a star topology. It is a topology that uses a central device called a hub. It can also use a switch. It is a more efficient device with cables extending in all directions. Each network device is connected directly to the hub or switch. Data from a computer passes through the hub or switch before it can reach the other target node. One of its advantages is the lack of disruptions to the network when connecting or removing devices. However, if the hub fails, attached nodes will not be able to use the network resources. So after we define the terms, let us now begin the tutorial. The first thing we need to do is to click the icon for Cisco Packet Tracer and then wait for it to open. So we're gonna just have to wait now. There we have it. Click the initialize button. That's it. So after we open the Cisco Packet Tracer, let us now be familiar with the parts of it. The first part is the menu bar. The second is the main toolbar, the logical toolbar, the common toolbar, the devices option where we can find the network devices that we can use, then the specific device option, the scenario box, and then a PDU list down where we can see if the message has been successfully sent. We're done familiarizing the parts of the Cisco Packet Tracer. Let us now officially begin the tutorial. So the first thing that we need is to have a switch. So we need to go to the devices option in the lower left side corner and click the icon for switches. We're going to use the 2950-24. Then, after putting the switch, we also need an end devices, so we need to go again to the devices option and click the icon for end devices. So we have many choices here, but we're going to use the PC-PT. And we need to put it around the switch, so we're gonna need 1, 2, 3, 4, and 5. We can still arrange it properly. So after putting the PC around the switch, we now need to connect the PC to the switch. So we need to go back again to the devices option and find the lightning bolt-like icon which represents the connection. There we can find the different kinds of connection. We have here the copper crossover which connects the same kind of devices, and we also have the copper straight through which connects different kind of devices. So we're going to use the copper straight through because PC and switch are different devices. So click and then click PC 0, fast Ethernet 0, and then click switch and then fast Ethernet 0/1. And then continue the process, PC1, fast Ethernet 0, switch, pass Ethernet 0/2, continue it until you're done. So now, after we connect the PC to the switch, we're going to put an IP address to every PC. So we need to click it, click configure, pass Ethernet 0, and then click the IP address, and then type 192.168.0.1, and then click the subnet mask, and then it will automatically show the 255.255.255.0. So let us first copy this for the next PC. So let's put it to PC1, figure, pass Ethernet, and then paste, and then put 2 because the PC should have different IP address. So continue the process. 3, figure, pass Ethernet, and address, paste, 4, figure, pass Ethernet, paste, and then put 5, and then subnet mask, and then we're done putting the IP address of every PC. So now, let's try to send a message. For example, we're going to send a message coming from the PC0 to PC4. So as we can see, it was successful. Let's send another message. For example, it comes from PC2 to PC3. It is also successful. Then PC1, PC4. It is also successful. Let's see how the message was sent. By clicking at the simulation bar and then click auto capture or play. So you can see how the message was sent. That's it, the reply. So as you can see, there's a check there, so it means it was successful. What if we remove the PC2? Will it affect the PC0, PC1, PC3, and PC4 in sending a message? So let's delete. Let's try to send a message coming from PC0 to PC4. Let's see if it was successful. Yes, it is successful. Let's try another to from PC1 to PC3. So yes, it is still successful. So this shows that even if we remove one end devices, PC0, PC1, PC3, and PC4 can still send a message. So that was the advantage of star topology.